Hi everyone, welcome to Chapter 11 for Algebra 2. This is all about probability. This first section is about permutations and combinations. What are those? How can we find them? All of that. We're going to divide this into two sections. So today we're just going to talk about permutations and we'll save combinations for the next time that we get together. The first thing we want to talk about is something I think you already know about, but I want to remind you. That's called the fundamental counting principles. It's just a number of ways that something can occur. For instance, if I have two pairs of pants and three different shirts, how many different outfits could I make? And you find that by multiplying 3 times 2. Or let's say I have three pairs of pants, three pants, 5 tops, and 2 pairs of shoes. So how many different outfits could I make? The fundamental counting principle would say you figure that out by just multiplying 3 times 5 times 2. Because with the 3 different pants, you have 5 different tops, so there's 15 different combinations. And then you can have each of those 15 different combinations with 2 different pairs of shoes, which ends up with 30 total different combinations. You multiply 3 times 5 times 2. That's the fundamental counting principle, which gives you 30 different outcomes. In using that, the book gives this an example. We have 2 license plates. One is an old license plate. It just has 4 digits. And the other newer license plate has 3 letters and 3 digits. Okay, 4 digits or 3 letters and 3 digits. And it says how many more, let me see how they worded it. How many more license plates are possible in the newer ones than in the older ones? So you use that fundamental counting principle. You figure each one of these digits has 10 possibilities, 0 through 9. So you have 10 possibilities for the first digit, 10 for the second, 10 for the third, and 10 for the fourth. So you multiply 10 4 times to get the total number of license plates that are possible, which seems like a really huge number, but it's just a 1 with 4 zeros. That's only 10,000 different license plates. And when you think about all the cars in a state, you're going to run out of possibilities really quickly. In this one, each letter has 26 possibilities. So my first letter has 26 different possibilities. My second letter has 26. My third has 26. Then this digit is 10, and 10, I have 3 digits. Each of those are 10. So the total number of license plates are 26 cubed times 10 cubed, which ends up being a really big number, 17,576,000. What did I say? 17 million, good grief. 17,576,000. So you see how many more that you could make here than here is just phenomenal. Now this is much more doable. Now you see why license plates these days have letter and digit combinations, possibilities. All right. Let me give you a problem just to make sure you understand how you can figure out the different possibilities. In 1966, one type of Maryland license plate had 2 letters followed by 4 digits. So 2 letters followed by 4 digits. Okay, that was in 66. How many of this type of license plates were possible? How many total license plates could Maryland have? So figure that out really quickly. Pause it if you need to. And you should have gotten 6,760,000 different license plates were possible with that. Okay, so that's the fundamental counting principle. You want to feel pretty solid with that. That's a review. I know I assume you've dealt with that in the past. Now we're going to go into permutations. And a permutation is an arrangement of items. So I have 4 different books I want to put on this bookshelf, or 4 pictures I want to put on the wall. How many different arrangements can I make with these 4 pictures? And that is called a permutation. If let's go back to my 4 pictures. I'm going to arrange them on the wall. How many choices do I have for hanging my first picture? Well, I have 4 possibilities. So for my first picture, I have 4 choices. Okay, now I've chosen one. So now how many possibilities do I have for my second picture? And you realize, well, I have 3 left, so I have 3 different possibilities for the next picture. Now I've chosen my first 2. How many possibilities do I have left for my third one? And you realize I have 2, and now my last one I'm stuck with, and so I only have 1 choice for my last possible painting. This is called a permutation, and the fundamental counting principle will give us all the different possible arrangements. It's 4 times 3 times 2 times 1, or 24 different. I can arrange those 4 pictures 24 different ways. Now there is a shortcut way to do this. We call this factorial. If you see this, and you may have seen this symbol in your calculators before, it looks it's an exclamation point. It's called factorial, and this is what it means. It means 4 times 3 times 2 all the way down to times 1. So find that in your calculator. It might be under probability. You might have a PRB button, and you press that, and you'll see a subcategory, and you might see this factorial. But rather than take your calculator and go 4 times 3 times 2 times 1, you could go 4 and use the factorial button, and it'll give you the final answer, which is pretty nice. Okay, you have 12 folders, and you're going to put them in a drawer. In how many different ways can you arrange those 12 folders? So you would use 12 factorial. How many different ways can I arrange them? It's that simple, which is the same as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4, etc., down to 1. And you realize there are, oh my goodness, 479 million 600 different ways you can arrange just those 12 files. And now we realize, oh, we like this factorial button. That helps us quite a bit, doesn't it? They get big really, really quickly. Okay, one for you. You have 8 shirts, and you're going to hang them up in your closet. In how many different ways can you arrange your 8 shirts on a closet shelf? So go ahead and figure that out. 8 shirts on a closet shelf. Pause it if you need to. You should have gotten 40,320. Okay, so that's just a basic permutation, and that's your factorial button. Now you know what that exclamation point is all about in your calculator. Now, we can use this to say, if we want to take the same idea, but only groups at a time. So, for instance, if I have, like, say go back to my pictures, but I want to know in how many ways can I arrange just from that selection of 4 pictures, 2 of them. So then what I realize is, okay, so my first picture, I have a choice of 4. And for my second picture, I have a choice of 3, and then I'm done. Notice I don't do the rest, so I only have 12 different possibilities. Do you see how that works? Because I am only picking 2 out of the 12. And that is called the number of permutations. So you will see, going back to my picture thing, this P stands for permutation, and we see this N and this R. This N stands for the total number that I have, and R is how many I want to make a group of. So I can go permutations 4, 2. I have 4 pictures. How many different combinations of 2 can I come up with? what this means is in factorial, and then on the bottom is you have the difference between this, the factorial of that. And that's what you actually you're computing. So let's say I have 10 items, and I want to know, out of those 10 items, how many combinations of 4 are possible. So what this would be then, this would be 10 factorial, and this would be 10 minus 4 factorial, or 6. And let me show you how that works, because 10 factorial, or why it works. I'm going to go ahead and take the time to write this out, because in the long run it will be so much clearer. 10 minus 4 would be 6, so this 6 factorial would be this. Now notice, I'm not going to multiply these big numbers. I'm just going to simplify this by cross-canceling. Cross-canceling. See how all these will cross-cancel? There you go. And you see, I just have my first 4 out of the 10. 10, 9, 8, and 7 is what I'm left with. Now your calculator can do this. So what, I'm not exactly sure, and I don't remember if you do the 10 first, and then you do this, find this button. Sometimes it's under a probability button. Click that and you'll find this. And then hit this and enter. Or if you hit this first and then this and this. I can't remember 100% sure. Let me get my calculator really quick. And I do have a button that says PRB. And I do have this NPR thing, this NPR button. And so I'm pretty sure I need to, I'm pretty sure I need to hit, so let me go 10, then under probability, hit NPR, and then hit 4, and then hit enter, and I get my answer. So yeah, for my calculator, I do 10 first, then I select this button, and then 4, and then enter, and it gives me my answer. Cool. Very sweet. So let's say 10 students are in a race. And the question says, from the race, first, second, and third places are going to win medals. So in how many ways can 10 runners finish first, second, and third with no ties? Okay, so first, second, and third out of 10. So what you have then is you have permutation, out of those 10 runners, you have 3, which would be 10 times 8 times 7, or 720. So you can go 10 times 9 times 8 in your calculator, or you can do this. And either with this, or figure out what that means, this is 10 over 10 minus 3, and you can figure out your answer that way. You should get 720. So experiment with that on your calculator so you feel really comfortable with how to find these different permutations. And let me give you one more. So there's 720 ways then that you can have first, second, and third place winners out of 10 runners in a race. So let me ask you a question. In how many different ways can 15 runners finish first, second, and third? So now we have 15 runners, 15. In how many ways can they finish first, second, and third? So figure that out. You should have gotten 2,730. There are 2,730 different ways that you can have first, second, and third place runners out of 15. So that's permutations. And your homework, online and written, should only be dealing with permutations. Next time we get together, we'll talk about combinations, and that adds another little twist to it. And the biggest challenge, I think, coming up will be when do you use a permutation and when do you use a combination, because they're kind of similar. but we'll deal with that when we come to it next time. So for now, just one half of the section. Enjoy permutations and factorials, and I'll see you next time.